what are we working on today? I have made the potentially good decision to start planning these out a little bit better and actually doing a planning session before each stream. This is the current planning document for Brane Engine. I downgraded Notion so it doesn't have a reasonable site name anymore. However, it is publicly available. Not at a URL anymore, but it is publicly available. The plan for today is, did I actually write down the thing that I was planning on doing today? I did not. I went through and added a ton of stuff to here, but not the thing I was actually planning on doing. Let's do that. Switch function calls to use native arguments instead of struct pointers. But right now, secretly behind the scenes, instead of passing in these arguments one by one, instead this is an anonymous struct definition. So the actual input to this structure is do you have a go on vacation? For the moment, yes. I decided it's been a while since I've done a face, I guess this isn't technically a face stream, but it's been a while since I've done a stream like this. So we'll just do it. This is the function definition every single function uses. We pass in the binding to the memory. This isn't going to change. We're not going to change that. And then this is a BraneScript function pointer. I32 is what we store pointers in. It's like a packed 2 U16s. The way that we return values, replacing the values of the struct that was passed in with the values of whatever return value. So that means the caller has to allocate memory space somewhere that they can pass a pointer to. That is the maximum size of either the input values or the output values. Whichever one's bigger, they have to allocate that much memory, and then they have to copy the input values into that memory. And then after that, they have to replace all of that with the return values, which doesn't make any of the functionality inside of the function less efficient, but it does make the actual act of calling a function have a lot of memory copying overhead. So what I want to do is come up with a method of reducing all of that. I don't want there to have to be a ton of copying into input values or copying out to output values. I would prefer that it's just works the way you would expect it to. Now, there are a couple of factors that complicate this. One is that I don't directly expose structs to LLVM. I do have structures in the intermediate representation, but I don't use any of LLVM's functionality for JIT compiling those structures. Instead, I just, in my abstract representation, instead of having actual struct operations, I just treat things like pointers and struct offsets, kind of like straight assembly code. Straight assembly code can't represent structs. And in the same way, my operations can't represent structs. I do store struct definitions for both debug and also reflection purposes, but not for actually JIT compiling stuff. And the reason why that's a big point is when we go to the LLVM backend, when we define this, you would have to, if we want to pass in structures and use something like the C calling convention so that we're actually able to pass structures into things, we would have to have the function defined in LLVM itself for passing into functions to work consistently between things. So that gives me a couple different options that I could go with this. One is to do what I did with BraneScript 1.0, and that is to completely say you can't pass structures into functions. You can pass references to them into functions, but you can't straight up say, put this data into the function. That is one option. And then secretly behind the scenes, when we return functions, we allocate some space on the stack before we call the function, pass in a pointer to that memory for the return value, and then trust the function to set those values. Or I could do a combination of all of those, which I think is the direction that we do have to end up going to make this as optimal as possible. Have you gotten a VR view working yet? Not quite yet. We're focusing right now on getting the scripting language working. After the scripting language and its scheduler are ready to go, we're going to put those into the engine and start on a rewrite of the engine's graphics system. When we start on the refactor of the engine's graphics system, that's when I'm planning on adding in OpenXR. And that is when we'll have a VR view working in the engine, somewhere halfway through that rewrite. All right, so we're changing the function signature from a pointer to memory plus pointer to input value slash output value union, because that's honestly what it is. When we pass it in, it's the input value. When we get it back, it is the output value. Instead, I'm going to indent this so the formatting's a little bit clearer. We're changing this to instead a set of rules, and that rules are break the a pointer to memory, followed by optionally a pointer to output struct location if output type is struct, and then break input structure member into types, into input struct into its members, pass each type member as an argument to a function, to the function as a native argument to the function. The native part is important. That means instead of passing in a pointer to memory, we're literally using registers, which are significantly faster. And then we also need to add in the caveat of if one of those arguments is a structure, we need to pass a reference to said struct instead. So this is now the calling convention of Brane script. Caller is expected to allocate memory on its stack or other memory, and pass memory at call time, and pass in memory, pass that pointer in here of the size of the output, not of the size. I'm gonna say for said struct at call time, and pass that pointer in here. Output values will be here instead of in function be here, and function return type will become a void. If function returns a non-struct type or non-object type, return value through normal function through native function. Cool. So this is a fair amount of work, but it shouldn't be too hard. It does mean that when we call stuff, we will always need to know its call signature instead of possibly being able to construct that at runtime always, which was the benefit of doing it through the current struct system, is if I want to be able to call any function through reflection, I'm able to do that. However, in this new system, if I wanted to do something like that, I would have to add like some form of jitting to turn an input structure or input buffer values into, and like throw those into registers and actually call the function. So I would have to like jit a little bit of a small helper function to actually call the function with whatever arguments. But at the moment, I was like thinking about this because I'm like, do I ever need to call functions in a generic way? And I'm like, actually, no. In the vast majority of cases, I don't need to call functions in a generic way. I may want to do something like allow the passing of very small structs through registers, so at some point I may need to upgrade this spec, but I think this will work perfectly well for what we need it to do for the foreseeable next couple months. No longer do we have a global function type. I can just delete that. This means for each one of our functions, we now have to create a signature. Fan this out to the full page so we can reference it. And then I will have to like throw this into the BraneScript documentation at some point. Do want a very well-defined API of how all this stuff works so that if other people want to embed BraneScript into their systems, there are defined API. There is a defined API for things, at least for specific versions. It probably will be a pretty regularly breaking API, but at least it's documented that it is like breaking and whatnot. Intermediate representation side of things. So instead of no op here, I'm going to change this to be instead arg value. I knew I was missing some important things here, but I hadn't put like add in function calls into the like actual thing yet. So add in function calls. Before that, I want defining non-pipeline stage functions, because currently the only way we're defining functions are as parts of pipelines. I can't define a standalone function quite yet. Since the compiler has already gone and put every single function that will ever exist into the BraneScript module, and we're currently iterating through that list of every function that will ever exist, it follows that I would never define another function type after this point. So I can create another function if I want to, but I don't need to. The first thing we need to worry about is the return type. If the function returns a non-struct type, we need to return the actual value regularly. If, however, we're returning, instead the second argument to the function will be a pointer to a pre-allocated bit of memory that we need to return to. So we need to do that optional switch here. With more than one member, caller is expected to allocate memory for said struct at call time and then pass a pointer. Output values will be at pointer, and the function return type will be void. That is an easier way to think about this. Get struct, and then pass in this function's output. I need some way to handle void types here, or int type, or handle that ourselves. It's like, I don't trust this generic function to handle all cases unless I start passing other arguments to this, like, hey, you're not doing input types, you're doing output types. We do want to match statement this. Void type, if we return one value, and on this branch of it, if we have a native value, we can just safely do self get LLVM type native return, returning this into a tuple, where on the left is what the function returns, and then this is going to be an optional, that is this optional structure return value. Then we also throw a none into that branch, but in the case of there actually being a value, we want to swap these, so instead we do a self context void type, and in the second value we return a sum, and it is always going to be a 32 pointer type. Okay, it's not implemented, so I do need to manually turn this into a basic type enum. Nope, today I decided to do a face stream just for the fun of it. It's been a hot minute and I'm like feeling guilty for not using my my camera. And then is it variable argument? Well, I already know I am not planning on supporting variable argument functions. I have literally never needed to use variable argument functions ever, aside from like print statements, and even then I would prefer to do a print macro type situation to handle that. That's why I wanted to see if I could do like inserting and iterating, because imagine I could just insert and then throw like one extra argument in there and then we just continue mapping. It would have been so clean. And then we want to say if let sum return. Alright, and finally we can say input args as slice. I don't want to be spending my time trying to cast enums. This is the less nice part about Rust. We go. Well, we now define function signatures not correctly yet. Return type if there's only one return type, otherwise structure if this is one structure. Okay, so if there are multiple return values, we want to return it as an implicitly created structure. Well, in this case it would never be native, so we don't actually have to do that match statement. Actually, no, this still would be an I32 type after that refactor, so it's fine. That is a proper function definition, I think. Yeah, the other errors here, we just have to make everything else fit. So one thing is arg value is now a thing. In this case, it's similar to load, but we're grabbing a, and is this already a basic value enum? It is, so I can just do get nth param like so. Perfect. So here's return, and I'll leave this as a to-do for now, because I'm not implementing full functions today. We're just implementing better function signatures that make sense. JIT function handle. These are going to have to be generic for now. I think I'll just use the backend specific type here. So address is LVM org address. Yep, that's a pointer. So I guess this is the type. I'll just keep it as an address until we request it. Now we get to move on to the compiler, or move back to the compiler. And here we have the fun task of recreating that logic. Where is input pointer used? Okay, this is where I'm dereferencing every single one of the struct members as an input pointer, but we don't actually need to do that because we're passing all the input struct members as actual arguments. I think for now I'll do this as an anonymous tuple. So we'll have the same thing I do here with the label. We'll have the actual label be first, and then the type be second. And now we have a list of all the types we need. This can be member type, but it's a option type context. Let's do less nesting of huge rustisms. That gets all of our types for the arguments. Honestly, a match could work here just fine. Giant chain of matches. Then on the struct type, of a struct type, I want this to be reference. I'll fix that when it breaks, and it will. If this is a struct type, we instead change it to native type. Let me just pass through the iron native type real fast. And this probably will get changed into a pointer type, but for now it's IR native type I32, which is an int pointer. And now we get to do something similar for the output. I do because I am defining it. So we'll still fully grab both of these structures. And then the types of each one of these is already going to be resolved, isn't it? Well, all I need to do is this final stage of, yeah, so it's ID. So that gets our arguments, except for in the case of needing to return a structure. Do I actually need to define an output type here? I don't think I do. Instead of doing input members, what we need to do is iterate over arguments. I'm going to do this the correct iteration way, which is args in iterator enumerate. Problem is that index isn't going to be accurate, because I need to reference this again. We'll move this get struct out into its own variable, and then index minus skip indices, and there we go. That correctly gives us the type, and if this is a structure, it will always be a mutable reference. If this is a native type we're trying to pass in, it's not a pointer type, or not a register, or whatever you want to call it. These are memory addresses, so we say is deref false, which I need to refactor that system as well, and I have that on the list of things I need to refactor, so it will be done. And there we go. We now have all of our stuff working. I need to convert these into function pointers. Let me get the current implementation of digit function handle, which is this, and I need to essentially write a custom pointer type here. So I have my memory page binding, I have my stack pointer, and then this takes in 3 I32s and doesn't return anything, because currently that is a 0 args is equal to, why did I switch to C? A is equal to 5, B is equal to 3, and C is equal to 6. So now I'm going to keep that same syntax. I'm not going to write it anymore. I'm going to call that return, because it actually is the return value now. Then we say we're running this with S0 args. That is such an unergonomic thing to type. Why did I do that? And then this returned. There we go. And now we can say running with, there is no C arg in this case. A is equal to that, B is equal to, throw all of this into an unsafe. There we go. That should still chain the call the same way, and it should work the same way, but this time we're actually using real function arguments instead of structures. Oop, that is an error on the back end. Well, let's look at the, arg is not a value. Arg is not a value. Let's just do this the non-fancy way, since my fancy way was very much messing it up. So we need a vector of input arguments. We also need the stack pointer here, which is not explicitly defined, or at least it isn't defined by the compiler. It's not part of the type. Let's throw an into on both of these and make the type of this a basic type enum, but it needs to be a basic metadata type, and then function type needs to be created after these two are input. So first we do the two predefined types that go into the function always, the memory bindings and the stack pointer, and then conditionally we insert a return point, and then finally we push the types of all the arguments. Now we shouldn't get the complaint that our function doesn't have a memory bindings pointer. We still are getting an arg is not value, error in members initialization. Wait, I don't need to write this because I access it implicitly. In fact, I don't want these to be accessible. And wait. Arg index. I don't want the other two to be directly accessible. I also need to do skip indices here. But I do want... Okay. I do want to write args here, but I don't want the stack pointer to be one of them. Okay, now it will write one pointer to a return struct, potentially, optionally, and then the rest of these will be actual arguments, and that potentially fixes it. still have the arg is not value. I'm thinking of the input pointer. I didn't give people access to the stack pointer. I gave people access to the input pointer, which in this case would be the output pointer. So some new thing is throwing off the indices of this, because we're not even getting to the point where we're trying to chit it yet. Arg is not value. We are compiling with the output struct, which is nothing, as the input struct. There we go. Now we actually are defining arguments to the function. That looks significantly more complete than before. So now we have arguments. I add args for not both int values. Pointer and sub I32. I add args for not both int values. I add args for... Well, now JIT isn't working, but compilation looks correct because we integer multiply 0 by 1. Yeah, look at how much smaller this is than it was before. Sure, we have all of this stuff to do with creating output structures twice, but on this one we only make an output, well, we still make an output structure twice, but the actual function right here, all of this is return value, stuff that we're going to optimize later. This is fine. If I had this defined as a regular function, not a pipeline function, there'd be one more thing here, which would be return, and that would be all it is. In function, now that error will tell me which function that was in. In multiple 0, I add, there are two I adds here. Couldn't compile function add multiple operation 4, which tells me it was this one. You're adding argument 0 to argument 3, which is 1 negated. Oh, I know what's going on. It's because we need this to be plus placeholder params. I could also just check the LLVM function. Or wait. I can do something super easily here. Super easy. I just do arg offset is equal to the LLVM function, count parameters minus IR function module get struct IR func input. If we've gotten this far, it will have already checked that this value exists. Then we can just say input type members length. Cool. Now every time we access an index, we just go, how many arguments does the user know about? Ah, they know about 3. There are 5 arguments. That means the first 2 arguments of this function are special arguments. So we're gonna ignore those and continue on with our day. And now we won't add a pointer to an integer. We have an error while actually calling the function. Wait, did it literally crash on the first instruction of the function? I think it crashed on the literal first instruction. Wait a second. Is it saying that this isn't valid? Like the function pointer? My code doesn't call functions, so it's trying to call this function but failing. Those are some suspicious looking zeros. Almost like that was sign extended. Reference to U64. So what if I just dereference that reference instead of straight up transmuting it? Well, the first one ran. Oh, that's to be expected. This is working. It's my caller code that's broken. Here, let me force the memory to be aligned. I just need this stack page itself to be aligned. Then I'm gonna make this a U32, and now it will align it, because I don't want to have to do standard mem dereference unaligned. Well, that's a good workaround for forcing aligned memory allocations. Ooh, wait. Now my dereferencing of things is incorrect, because add adds the size of the type. Here we go. 5 minus 3 is in fact 2, and then 6 is carried over, so that is working correctly. We get 12. Let me check what my current example script is. The 2 values times each other. 2 times 6 is in fact 12. So we can say that the refactor is in fact working. I don't have any code that uses return values yet, so might as well be working. We'll figure out if that isn't working when we add in more functionality that actually requires that. Well, yeah, function calls will actually be fast fast now. When I was thinking about turning all of this into a stack machine, I was like, oh, I'll just pass values into functions on the stack and it will be fine because everything else will be on the stack and it will all be optimized by LLVM. And I'm like, I don't like the idea of functions themselves being a bottleneck for my scripting language, because then data throughput itself becomes an issue and I want everything to just be fast by default. So we're putting in the extra effort. We're actually doing functions with arguments, and then if I ever need to do reflection-based calling of functions, then that's my problem. We'll JIT call those. Let's go and commit this. There we go. For those of you who stuck around, thank you, and I will see you next time.